Good morning, wine growers, and thank you for joining us this morning. I'm excited to introduce these speakers to you because they both have such a strong passion for their subjects, and it really comes through in their teaching. In fact, I think these two gentlemen will have you so engaged and curious about soils and cover crops that you're not going to want to even need to get up for that second cup of coffee. James Cassidy introduces students at Oregon State University to soils, where he's known for his enthusiastic style and ability to transform the dirt under our feet into a miraculous matrix of living, breathing soil. Today, James will explain what defines high quality soil in the context of vineyards and how we can influence these with our management practices. Following James will be Steve Groff, who comes to us from Pennsylvania, where he's well known for his pioneering work in no-till agriculture. His innovations include design of the first cover crop roller crimper and development of the first tillage radish. Steve is here to inspire us to think about why we should be using cover crops if we aren't already, and how we might utilize them in ways we haven't yet even thought of. Unfortunately, there will not be time at the end of this session for a discussion. However, the presenters are available to respond to your questions during their pre-recorded presentations. So please feel free to ask away in the chat feature on your screen. Enjoy.
Okay, thanks, Rebecca, for the intro. And yeah, I teach at Oregon State University. I teach these large introductory soil science classes. And today I'm doing a very short presentation on soil and what it is and how it works, and getting into a little bit of some of the details about some of the advantages or the physics maybe of cover crops and how water moves, and we'll maybe have time for a demo. So soil, what it is and how it works. Essentially, it's all about it's all about soil. I mean, everything's about soil, and I'm not just talking about grapes. I'm not just talking about food. I think everything. I mean, every atom in your body has been through the soil system billions of times already. And the fact that you are not soil at this moment is a temporary condition. I happen to have some soil right here. It's right here. I don't know if you know this, but in a single pinch of soil, here's a single pinch of soil, there are over 1 billion living organisms in here right now. They represent tens of thousands of species. I mean, this is where life on the planet is the soil. By any measure, the most diverse habitat on the planet. If you get nothing else out of this talk, if you can internalize the idea that soil is habitat, and this is, and once you get that, you know what to do to it and what not to do to it. And most people never think about any of this. And so I really encourage you to try and just in fact, go out on your hands and knees today and just take up a little bit of soil and just imagine that there are billions of organisms in a single pinch of soil. And once you can kind of get that, maybe that will help inform what this is all about. And really what we're doing is we're feeding the soil, and the rest of it comes along for the ride. Okay? So, and what organisms in the soil need is organic matter. That's what they need, just like we do. We eat organic matter. And that's what the soil organisms do as well. So, I keep going backwards. Bottom line, soil is habitat. Habitat for what? For everything that is alive on this planet, essentially. And there's more life underground than there is above ground by orders of magnitude. When you're talking about numbers of organisms, diversity, even mass of organisms. And I'm going to cut to the chase right now because we've got a very short amount of time. But you want to know what the answer is? It doesn't matter what the question is. Do you want to know what the answer is? The answer is add organic matter. Add organic matter. Say it. Add organic matter. Because when you're adding organic matter, what you're doing is you're adding carbon from the atmosphere and energy from the sun. That's what organic matter is. It's plants eat the atmosphere, carbon from the atmosphere and energy from the sun to take apart carbon dioxide and put it together into carbon to carbon structures requires energy from the sun. And that's what food is. And so by adding organic matter, you're adding carbon and energy to the system. And that energy is what powers the biology of the system. Okay. So, and there's a lot of different kinds of soil. This is another thing I really can hope you can understand, that there's different soils in different places. So there isn't really one way of thinking of the situation. You have to really know that there are different parts. And here are just, I'm not going to go into this in great detail. I'd love to come back sometime and do that. But for instance, there's 12 soil orders, and you can really see the difference between these two soils very easily. And you'll notice that they're arranged in these, what we call horizons, right? And the surface horizons here on the right, this mollisol, this is all this black here is because it has a lot of organic matter in it. So it has a lot of carbon and energy in it. So it has a lot of biological activity in it to process and move nutrients and make them available to plants, which adds more organic matter, which makes it a better habitat, which adds more organic matter, which makes it a better habitat, which adds organic matter and increases the nutrient supply capacity and the water holding capacity of the soil. So adding organic matter does that. And that's what cover crops, the easiest way to add organic matter is to simply grow it, grow organic matter. So here's just a couple of the soils. Just wanted to show you what they look like. And you can project this over the entire planet. These 12 soil orders, and you'll notice that there's mollisols. These are these very rich agricultural soils that we have in the Midwestern United States. And we have desert soils, and we have tropical soils and frozen soils, and there's all sorts of interesting things. And it's not just globally, it's locally too. Here in Oregon, we have all of the 12 soil orders except oxisols and gelisols, and really you don't need to know what those are, but these are tropical soils or Arctic soils. So we have all this diversity of soils. It's a very interesting place to study soil. In fact, I just want to show you really quickly, switch cameras here. And I want to show you, I'm in my teaching lab right now, but I want you to look at that. Over here they are. So these are, what I'm hoping that you get is that these are actual specimens of real soils that have been mounted, if you will. Right? And these are Oregon soils. Now there's thousands or many hundreds of Oregon soils, but these are just some of them. And what I want you to try and imagine is that when you're walking on the surface of the soil, you're up there, just think about what's going on underground. And not all soils are infinitely deep. Some of them are very shallow soils, some of them are very deep soils, and it really can vary on your property, their vineyard. Even though it's mapped as one kind of soil, a different slope, a different hill might actually even be mapped as the same soil type, but it will actually be thinner and have less water holding capacity and just be different. So think about that. I hope you can internalize that. I'm just going to come back to my slides. So here, I just want to show you the actual soil. If you look at it right over here, we zoom in on that, come to that, you can actually see that these soils are different. And you'll notice that they're made up of little particles of sand, silt, and clay. And this one's a little darker, this one's a little lighter, but this is real soil. Even this soil right here has billions of organisms living in it right now. So back to the slide set here. So we have all these different soils here. So try and just imagine that when you're walking around that you might have different soils. You can see different horizons. It's more organic matter near the surface, and it actually goes down. You go down far enough, and there's rock down there. So it's actually very thin. Soil is a very thin skin, if you will, on this rocky planet. And all life happens in that tiny little thin surface. And just dig a hole and see how deep your soils are. and just start thinking about it that way. So what soil actually is, soil is rotted rock. And I use the word rotted because most people know what that means. But really, maybe you don't know this, but rocks dissolve in water. And what a rock is it's just elements, right? These are different elements in the Earth's crust. There's like 118 elements in the periodic table, right? And that's what these rocks are made out of. And if you look at this one up close, you can see this is it'll come into focus in a second here. This is like a granitic rock. Come on, do that for me. And in these different colors, these different crystals are different minerals. And different minerals are made up of different elements. So these are crystalline elements. Now, what this thing is actually just nutrients. I mean, this is what you're made out of. This is what your plants are made. This is what grapes are made. This is what wine's made. The glass that you put the wine in is made out of these elements. And to get these elements into a form that plants can take up requires that they dissolve. Now, maybe you don't realize this, but rocks dissolve in water. And you might think, what are you talking about? I mean, we build pyramids, and they will dissolve. Even the pyramids of Giza will eventually dissolve away. And so it just takes a little longer than we have patience for. Maybe it takes 1,000 years or 5,000 years for this rock to completely dissolve away. And I have a little water right here, right now. So I want you to watch. I'm going to put a little bit of water. And see that? It's dissolving right now. Can't see it, but it is. A tiny little bit of that water is dissolving a tiny bit of those minerals out. And that is becoming a mineral nutrient that plants can then uptake. And that's what's in you. I mean, your body is made, 80% of your body by dry weight. After you take out the water, it's just a little bit of minerals, right? So that's what soil is, dissolved rocks. And when this thing dissolves, you'll see these different size particles. Some of them dissolve fast and some of them dissolve slow. And eventually this breaks apart into sand, silt, and clay sized particles. And then they are dissolving and being released as mineral nutrients that the plants take up and use in their machinery and their DNA in order to capture energy from the sun and carbon from the atmosphere and grow. And so the roots go down into the soil to get those mineral nutrients. So that's kind of fundamental. And then the other thing that soil is decomposed organic matter, right? So there's dissolved rocks, and then there's this decomposed organic matter. And here's a very simple pie graph that I think is instructive. And this is really what soil is. It's a bunch of these minerals of different sizes, sand, silt, and clay. And then this little slice here called organic matter. And 5% organic matter is actually a good amount of organic matter. And then what the most important part of this image is this idea that the rest of it is space. Okay? So the soil, here's a piece of soil, right? Half of this is space. And what's in that space is either air or water, right? And that is determined by the size of the pores that are in this. Now, this is where we're really starting to get at how cover crops can manage that. Because you can have a soil that has 50% porosity that has one big pore in it, or you could have lots of little pores. And it's the size of the pores that determines how fast the water moves into the soil and how much water can be stored by the soil. So I'm going to switch to a different slide set here because I really want to get into this a little bit deeper with you. So remember, soil is about 50% space, right? And large pores drain under the force of gravity, and small pores, they hold water against the force of gravity. So large pores drain and small pores hold. Think of a sponge. Think of a towel, right? Think of a paper towel when you wipe up a spill, it sucks up the water by capillary force and it holds it against the force of gravity. And that's how soils store water against the force of gravity. So I don't know if you can see this. Look at my finger right here. And if I put a little bit of water, you should all do this, take a bath. And if you look carefully, you can see that little bridge of water between my fingers. Can you see that? That little bridge of water. See, small pores hold water against the force of gravity, and large pores drain into the force of gravity. Small pores hold water, large pores drain into the force of gravity. And it turns out it's about 0.08 millimeters is where water, what we call a micropore or a macropore. And macropores, if they're larger than 0.08 millimeters, drain into the force of gravity. And micropores hold water against the force of gravity, okay? So the rate at which the water goes into the soil is determined by these pore size distribution. So let's see. So we can measure the rate at which the water goes into the soil by simply putting a coffee can on it, essentially, and running some water and seeing how fast it goes into the water. And a dry soil will actually suck water in and the force of gravity. So you'll get a very high infiltration rate when the soil is dry. And so it starts out at a very high rate, and then as those pores fill, it slows until it comes to this asymptotic sort of one rate, and that is called the K-sat, right? And that's the saturated hydraulic conductivity. Don't worry about it too much, but it's the rate at which the soil brings in water after it's saturated, because it continues to do that. And so here's what I want you to look at this little graphic here. So here is a little aggregate, right? This is like a little clump of soil and another clump and another and another. And you'll notice that there's these spaces between. So these are large pores in between the aggregates, and these are small pores inside of the aggregates, okay? So when you irrigate or it rains or some precipitation event happens, the water is pulled in by gravity. See how that just like pulls in the macropores, right? And then once that water is flowing through those macropores, it gets sucked into the little micropores inside of those little sponges. And eventually those become completely filled with water. And then the soil drains. And now you've got air again in the soil. And the thing is, plants need water and air. You know when they need water? All the time. You know when they need air? All the time. So that's why you need soils that have large pores that are drained and have air. Because think about it. When the water is draining from the soil, as that water droplet goes down into a worm channel, what's being sucked in behind it is air. And so when you oxygenate the soil is breathing. So when a soil is draining, it's actually breathing. It's pulling in air. And those billions in a single pinch, you know what they need? They need oxygen, just like you do. And they also need water. And where's the water? Stored in the micropores here. So this is ideally what you want soil to be like. I use the term a wide pore size distribution. That means lots of macropores, lots of medium pores, small pores, tiny pores, and little itty bitty tiny pores. You want all those. And when we till soils and when we drive over soils that are wet, we tend to crush the macropores away. And we end up with mostly micropores. And when you have mostly micropores, you just don't have the drainage, you don't have the infiltration. And so you have these kind of wet, waterlogged soils that are low oxygen. And that's how plants drown, is that they just don't have the oxygen and the drainage. Also, a well-aggregated, stable soil pulls in water and it goes down deeper instead of running off. And so here's an image of what happens in runoff. Is you get this water coming in, and if it can be sucked in for a while, but at some point it meets this line where this maximum infiltration can happen, and then you end up with what's called runoff. So if you exceed the infiltration capacity of the soil, with the irrigation or precipitation event, you get runoff. And when you get runoff, runoff carries away the small particles. And the small particles are the ones that do the business that you really are interested in. Clay and silt. Clay especially holds the nutrients. So when you have runoff, you're losing clays, which reduce the nutrient capacity of your soil. When you have runoff, the other thing you lose is organic matter because it's light in weight. It's a low density stuff and it floats away. So the two things that make soil soil are lost in runoff. And the way to prevent that is to make sure you have a wide pore size distribution. How do you do that? You minimize compaction and you build wide pore size distribution with roots. And so what a root is it's a tiny little thing that grows into a tiny little pore and then it gets bigger and it pushes the particles aside. I mean, think about a tree root, how big those pores are. And eventually, the organic matter that makes up the root is decomposed. And what's left behind is a casting of the root that was there previously. And what does a root look like? It's got a big part, a medium part, small part, and tiny parts. And so what do you end up with? A wide pore size distribution just by growing roots in the ground. And this is one of the super important functions of cover cropping, is to have a wide pore size distribution. The leftover information from the previous generation of roots leave behind a complex pore structure. Also, when organic matter decomposes, it leaves behind a little bit of glue. Yeah, glue. It glues the particles together to make those pores more stable, meaning they don't fall apart when they get wet. So by growing organic matter, by having roots in the soil, you're increasing the pore size distribution and you're making it more structurally stable. And so what does that do? High infiltration rates, good oxygen entering, deep water storage, less runoff. And so you maintain, and then and because all of that increases the amount of organic matter that can be accumulated there. And that's what soil building is. By increasing the organic matter content, you make the soil a better habitat to increase the organic matter content, which makes it better for increasing the organic matter content. See how that works? That's what soil building is. And the opposite of that is when you have low infiltration rates and runoff. And when you get runoff, you start to lose the organic matter. You start to lose the clay that allows you to grow things. And that's the downward spiral of soil degradation. I don't know if you want to know this, but every 6 seconds, we're losing a hectare of productive soil on this planet. Every 6 seconds. That's like a football field just going away every 6 seconds. And every 6 seconds, there's 8 more people on this planet. You don't have to be a mathematician to figure that out, what that means. All right. So, I'm not going to spend a huge amount of time on all these slides. I have a billion of them, of course. But here's the thing. Infiltration is affected by soil type, the cover that you have on it, whether or not it's compacted, et cetera, et cetera. And you might be thinking, what does this have to do with cover crops? Well, here it is. See these things? The structure, the aggregate stability, and the compaction are things that you can manage to improve the infiltration rate of the soil. You can't change the soil type, right? You can't change the topography, but you can manage for stable aggregates and good wide pore size distribution structure and minimize compaction, right? And so here you can see here, under normal, quote unquote, soil, native soils, we have good infiltration and good aeration. And inside of these little micropores, we're storing lots of water, right? In compacted soils, it's kind of the opposite. And we end up having low infiltration, runoff, and the downward spiral of soil degradation. Right? So that's what cover crops do, is they improve the soil structure by punching bigger holes into it with their roots. And when those roots decompose, they stabilize the aggregates so those macropores stay there a long time, and they can actually reverse compaction. There's just this constant struggle with farmers that I see who want to make their soils infiltrate better, and so they think tillage it will do that. And it's not like it's kind of there's a logic to it. I'm not going to get down on that. Well, you think you're fluffing the soil up so that the water will go in, but what actually happens is you break up all the macropores, you shred up all of the organic matter that's connecting and holding it all together, and then it compacts, and then you have low infiltration because all the macropores are gone. And so if you're trying to get the water to go in and be stored deep in the soil, you want to minimize that disturbance. And here's just an example, right? Just kind of a graphic, right? You can see how those roots are making these deep macropores, and over time the soil becomes more well structured and more stable in its structure. Where over here we got compacted zones. And so actually what this really does is it makes the soil thinner, because this isn't really good habitat down here. So this is the good stuff right here, where here there's a lot more of the good stuff. So there's more soil that is biologically active. And that's something you can manage just by paying attention to what's going on underground, and really thinking about every step you take. You're on top of an ocean of soil. And how deep does it go? And what does the pore size distribution look like? And is it well aerated? And is it storing water? And is it a billion in a single pinch in that soil? How deep is it? And that's where you need to get. And once you get there, you can sort of figure a lot of this stuff out yourself. It's not about reading a recipe on what to do. It's knowing how to cook. And knowing how to cook is understanding the fundamentals, right? And so the fundamentals are understanding that it's the pore size distribution. I hope you get what I mean by that. Large pores, medium pores, small pores, super tiny pores. That's what you want. And the most vulnerable pores in your soil are the macropores. And then, because, there's a lot of small pores in there. But managing those pores, really, you're not really farming. You're ranching microbes. And you're not really ranching microbes. You're managing space. The empty void is really what you're managing. And if you can get your head around that, put that in your pipe and smoke it. Think about that. And then that's really what you're doing, is you're managing the soil, you're feeding the microorganisms, and the rest of it comes along for the ride. And I mean the rest of it, like all of it. What we think of as our lives and civilization. So here's an interesting fact too. And that's the soil organic matter store itself, just by having organic matter, it actually holds water 80 times its own weight in water. And look at this stat. For every increase in 1% soil organic matter that you can attain by doing good soil management, you can store up to 25,000 gallons of water per acre. More of it. That much more. And it's not just me saying that. This is the NRCS. Every 1% increase in organic matter results in as much as 25,000 gallons of available soil water per acre. You know what the first thing lost in erosion is? Organic matter and clay. And those are the two things that make soil that make you able to grow stuff. Maybe you won't notice in 50 years, but in 100 years, it makes a difference. Sooner or later, we're losing the productivity of the soil. And every 8 seconds, we're losing a hectare of soil. And every 8 seconds, there's 8 more people on this planet. Right? So to increase infiltration, we want to increase the stable pores. and minimize compaction. To increase water retention, we want to increase infiltration at greater depth by having increased infiltration, and then increase organic matter, soil organic matter. So add organic matter, that's the answer. And the easiest way to add organic matter is to grow it, because you can put on compost or whatever, but that's not a root penetrating into the soil making a macropore. So this is just one, I just wanted to kind of focus in on this kind of one little slice of understanding how this idea of cover crops has a real physics impact that has an actual outcome here on productivity. So I think I'd like to just get to a couple of demos. And but before I do that, I have to show you these incredible drawings of roots. Look at this. Think about this. When you see a little weed at the surface, look at this root. Look at the complex. Eventually, that root is going to rot away and be gone. And what's going to be left is this pore, this complexity of pore. There's a macropore that brings the water all the way down. There's micropores that bring it out here, and there's tiny little micropores that are holding the water. Look at the surface area of that pore created by that one plant. Or look at this one. Or look at this one. Look, these are this is zones of compaction. They're keeping it from going any deeper, etc., etc. Just think about that. When you see these little plants, and you can control the pore size distribution, the depth and the width of all that by selecting the plants that you grow. What cover crops are you growing? So I want to show you this quick demo. And here's a high disturbance area and a low disturbance area. And I took these cores out. It's a special little, it's called a rainfall simulator. Maybe you've seen this sort of thing in videos. I have not run this today. So this is just like, I hope it works. It always does. Except this time, I don't know. It always works. So I'm going to move over to a different camera over here. And first, I just want to show you two pieces of soil. This one on the left has a lot more organic matter in it, and this one on the right has a lot less organic matter. I'm going to put them in this water and see what happens to them. And what you'll notice is that the one on the right, because it has less organic matter, is just falling apart. It's falling apart rapidly, and eventually we don't have enough time. This thing will completely fall apart into small particles. And what's happening to the pore size distribution in here? It's falling apart. Where this soil here is maintaining a good pore size distribution because it's got stability, and that's because this has lower disturbance and has had lots of cover crops on it. Where this one has been tilled a lot, and it is, and it hasn't had a lot of cover crops put into it. So there's that. Now look at this over here. Same soils. In fact, these are identical soils. They're just managed differently. And the one on your left, look, it has cover crops and grasses in it. The one on the left, on your right, sorry, has been tilled a lot and not had a lot of organic matter additions. I'm going to add 800 milliliters of water to the top of this rainfall simulator, and we'll watch what happens. And I don't know if you can see what's happening. It only takes a second, but you'll see that the one that has the macropore channels in it from the roots is actually having much less runoff than the one that doesn't have that. I even capture all of it. And you can see, and look at the quality of the water now that it's stopped raining. Look at that. You see that? That is your clay and your organic matter that has been lost to somewhere else. That same soil is being held in place by these roots. And what's equally interesting is look what's happening underneath. This one, more water is going deep into soil into the water, soil storage, water storage, than on this one. And look at the quality of the water. This is clays that are clogging pores. I know we're almost out of time, and I hope that made some sense to you. And I'm very excited to take your questions in our next session. And I think that's what we're going to call it. Cool?
Well, hello, Oregon. I'm so happy to be here today, and I wish I'd be in person, but we do the best we can in this day and age, I guess we'll say. So you might be asking after you heard my intro, why do they get a Pennsylvania farmer to talk to you guys who really doesn't know much about growing wine or having vineyards and so forth? What do I know? Well, I do have a grapevine right out by my house. My grandmother planted it in 1940s. Does that count? I don't know. We enjoy the grape juice we get off. It's an old Concord variety. So I'm just going to get right up front and say I am not coming to you today as an expert in using cover crops in vineyards. That being said, I think you'll see as this goes through, I got a little experience. I've traveled the world talking about cover crops and soil health and so forth, and all different kinds of climates and all different kinds of situations. So there are certain fundamental principles that apply to everywhere in the world. So that's what I want to share with you. And I'll just say right up front as well, I'm not going to be giving you detailed, specific advice. Those answers to those questions will come from the rest of the attendees in this group. You guys can figure that out. So I'm going to give you a little challenge to that. That's your job to do. I want to inspire you, to educate you to how to think about cover crops, to know why you're doing it so you can figure out how to do it. So that's a little bit of the approach of where I'm coming from. You see, I don't think that this is the future where we have bare ground or we have soil showing, uncovered soil in our wine production. And there's a lot of reasons. I'm not going to go into all that. I think you already know that. If you're watching this, you're probably interested in soil health. Is soil health in your future? You're going to have to want this because I'm going to tell you right up front, this is not easy. And some people say, well, that looks ugly. That doesn't look right. I get that. I understand. But this is kind of where things are headed. So this is why we're having this talk today, to help you understand why you're doing this and why we are going this route, using plants, cover crops, and why we're employing some of these soil health principles. It can be beautiful, by the way. And some people get into this complicated, complex mix of species where you have different flowering and different colors. And actually, that picture that we see right there is a thing of beauty, I think. So it's not all just because it's different doesn't always mean it doesn't look right. This is definitely something that does have eye appeal for the public. We're going to talk more about that later. So how can we apply these soil health principles, the using of cover crops, and maybe even not even tilling the fields or the vineyards? How can we apply these to vineyards? Well, let's start out with your mindset. Mindset matters. Here's two things. If you're the type of person who says, well, Steve, I guess I'm going to give this a try, or you might say, I'm going to make this work. I know there's, some caveats to making it work. I'm going to make it work. Which person has the most effective chance of succeeding? Which mindset are you? Where do you fall in this category? And I'm telling you, if you really were serious, if you think this is the future, you're going to make this work. So that is where the mindset matters comes in. It really does make a difference. And one of the things that I kind of live by in all that I do in the soil health is, how can I mimic nature? What can we learn from nature? Because we've kind of forgotten how to farm this way in the past 50, 60, 100 years. So, this is a picture from my woods, and you can see it's nice and green, it's vibrant. I'm not seeing any insect problems. I'm not seeing any disease problems in there. Not saying that never occurs. No pesticides applied. No fertilizer applied to this. How do things actually grow? And these are the things that I go to bed at night thinking about. How can I apply these type of principles in my farm, on my vineyard? I'm not suggesting that we go out and forage for berries and nuts. Don't think that would go over very well for our society. But the principle here is, what can we learn from nature? And I think that is key. We need to work with nature. Over the past decades, we've been taught to control nature with tools. What am I going to kill today? And that's been our mindset. I would suggest a different mindset. How can I get more life into my operation? How can I mimic nature? How can I nurture it? That is the direction that we're trying to head here, and what I want to help us along with today. You see, most farmer education comes from the retailers who are selling them products. Think about that. Is that true? Is that true in Oregon? It's true here in the Mid-Atlantic. And I think it's important, again, to understand how all this works, and because it creates some of the challenges. So just think to yourself, who are the champions of promoting soil health? Who are they? You probably could name a few, because they're scattered around. They're literally scattered around the world. Who are those champions of soil health? Well, probably not your pesticide or your fertilizer dealer. Nothing against pesticides or fertilizers here. I just want to make sure you understand a little bit where I'm coming from. I use some of that. I try to use as least possible. Try to understand where they be used. My pesticides have dropped dramatically. My fertilizer is kind of following suit, dropping dramatically. And this is kind of where I'm on track. This is what I want to do. I'll just say too, I am not an organic farmer. I don't intend to be one, but I do intend to try to use less inputs. And this is important, again, to understand in the context here. See, nobody's out there selling soil health. You can't just go and buy soil health in a bag or a bottle. Now, there's components out there, but it's really more about management. And as we think about our vineyards and how we're managing them, it's you, the manager, who's going to make a difference. You can't buy soil health in a bag or a bottle. And it comes up to you to accept, to embrace a level of management that you may not have known about before. See, we have centuries, millennia of experience of growing grapes, of growing wine grapes. And there's certain things that are tried and tested, and this is the way it works. This whole industry is the way it works. I get that. But as we go through, as we evolve as a society, we learn new things, and you do have to change or you may become obsolete. I don't say that as a threat. I just say it as something to consider as you think about the future and where the future is headed. I'm going to kind of wind up my talk here today talking about where the future may be headed and why you need to consider this, particularly from a marketing perspective. So it's important to understand this. You see, the fear of losing yields is a powerful marketing tool in agriculture. And I get it. You know, I'm a farmer, and it's certainly, you don't want to lose yields. I know it goes without saying, but you don't hear about many contests that give awards for your most profit per acre, right? You don't hear that very often, but that's really what it matters to us as a farmer. And I'm saying, if we do this right, I think you can be a profitable, sustainable, long-term farmer in what you're growing. Now, this all sounds great, and if you're just theorizing all this, you're like, yeah, that sounds great. Show me the data. Where's the research to support all you're saying, Steve? And I know there's been other talks here that have gone on in this conference that give out some research, but I got to tell you, our research is way behind, way behind. You think about all the money, the millions, if not billions of dollars spent into research of the products that we buy. Well, that's why we use them, because they have proven them to work, or at least, we get that perception. Just think if just maybe 10% of that money would be put into soil health, what we could learn from that. It's a little difficult to do when you can't put soil health in a bag or a bottle. Follow me there? So researching the influence of biology is slow and hard to quantify and is affected by many variables. You just got to understand it. It's just where we're at right now. I would assume 5, 10, 20 years from now, we're going to get a better handle on this. Again, this is where we're headed. So the farmers who are on the cutting edge don't have patience. They're not going to wait for university approved or recommended practices for regenerative agriculture. This is pretty much a farmer-led movement. And I'm not discrediting anything, any of those you work for non-farming agencies, the USDA or NRCS or universities. We're grateful for what you're doing. That being said, I will have to say, I think it's pretty much a worldwide thing that the farmers pretty much are driving this or have started it. And now universities, so forth, are picking it up to try to see how it actually works. So here's a little pro tip. You're starting to think, well, where do I start? The best place to start when you're talking about cover crops and soil health is understand and determine, what are you trying to accomplish? What is it? Is it erosion concerns, especially if you're on a slope? Is it more organic matter? Is it a more resilient soil to weather extremes? Could be any one of these. Is it a marketing advantage that I alluded to? We're going to talk about later. Could be many other things, but you got to think about that. Because if you don't have an objective, if you don't have a goal, you're going to be the person who says, I try to make this work, and not the person who says, I will make this work. Very important to know what you're trying to accomplish in your situation. And there are no shortcuts. Just because you plant a cover crop one year to get a subsidy from the NRCS doesn't make you a soil health expert. I've been doing this for very intensely on my farm for 25 years, and I'm still amazed at all there is to learn. I will never figure it out in my lifetime. It's a whole lot of good information out there. I'm firmly committed because I've seen the results. I'll just quickly say, in my farm, organic matter is nearly tripled. And that is really gratifying in a way to see tangible results. We can measure that. That we can. So, what are you trying to accomplish is huge if you're going to be trying to get to the point where something is positive here. Other thing a lot of people don't understand, because we're wrapped up into kind of an annual paradigm, the way we think about things. Did it pay this year to use this fungicide? Or did it pay this year to fertilize in such a way? If we're talking biology, I'm saying, I'm going to challenge you, think about it as a 10-year plan. I have this little chart here. Sorry, doesn't talk about vineyards. It's corn, beans, and wheat. It's a kind of a cool diagram. I thought, well, it's going to make my point for you guys. Where the key to this chart here, this graphic, is that something is growing all the time, year-round. And again, you're going to have to adapt everything to your local system. Again, I'm not going to get in details. You're going to have to figure out the details. But think of it as a system. It's just what you have to do if you're going to succeed in this. Trust me on that. All the cover crop champions and soil health champions, they'll all agree with this. It's the system. It's a systems approach. It's a mindset. And you have to be able to do that in order to be successful. Kind of following up on what I said there, you got questions, we got answers. And I'm highlighting that. You're going to have questions. You're going to have questions that get answers, and then 2 more questions are going to pop up after that. Trust me on that again. We got answers. Who is the we? It may be a mentor that you have. It may be a neighboring farmer. It may be a farmer in France, somewhere halfway around the world that's doing similar things to you. It may be the NRCS. We have some good people in the NRCS that has some experience, or they know other people, can connect you with them. University, even industry does have some good people to help answer some of these questions. So this is not a Lone Ranger mindset you got to have here to make this work. It takes a we component, multiple people. And I'm just going to encourage you to get your best information from the people who are already doing what you want to accomplish. If you know of anybody out there like that, that's the best, the most ideal way to start. So that's a good piece of advice. Ideally in your local area, if not in another geographical area, but then you have to kind of work with the geographical differences, weather, climate, and all that stuff, and make those adjustments for your region. So I know this is complex. I don't want to discourage you, but I want to give you straight farmer facts. The story, and I'm saying here the story here, I'm going to capture it as regenerative agriculture, soil health, whatever term you want to put to it. That story is compelling to the end user of your products. Remember that. I'm keeping to kind of tease you a little bit here from a marketing side. This is where the marketing comes in. You see, it's a rat hole if you try to explain to your typical consumer why you use some fungicides or why you use some pesticides. It's just a little hard to explain that. And I could in a way that would give reason for it, and some people understand. But when you say that you're using cover crops to protect the soil so that it doesn't erode away, to protect the water, some areas more than others, so that the water doesn't get as polluted, all of a sudden you got a customer that really appreciates what you do and they appreciate your story. And I think that's going to become more important as we go along here in our journey to understanding soil health and how we apply it to each of our vineyards. So this isn't all fun and games. There's challenges. And I'm just going to be upfront. It's hard. It's hard. It's not easy. Concept is simple, easy to understand. Soil health, cover crops. The challenges are difficult. So that's why I'm saying you got to do all these things, your mindset, embrace the challenges. So I'll list a few of them. Cost of seed, that's one of the first things. Do cover crops pay? That's what got me into doing research back in 1995. I started doing research with the University of Maryland here in my farm. And we did 12 years. It's rare you'll see university research involved in long term. And it wasn't until the fourth year till we really saw meaningful differences in yield. And it was a dry year. So that drier year showed up the advantages of cover crops. And from then on, I've never asked the question, do cover crops pay? Now, I'm prudent about it. I'm not indiscriminate. But the cost of seed is a real issue. Now, I know there's cost share available, and I would encourage you to take it. What we're seeing here in the Mid-Atlantic, and I'm just giving this as what we're seeing because of the Chesapeake Bay issues. It's been an awareness for the last 30 years. The majority of the farmers, you may be surprised to know, don't bother with the subsidies because they don't like some of the strings attached, the reporting and all that stuff. We think it's right around 60% take no subsidies. Now, I will give a caveat. The state of Maryland, right south of me, does have a very generous cover crop program. So most of the Maryland farmers take that. My state of Pennsylvania does not have subsidies. You can get some through EQIP and other NRCS programs, but even so, the farmers around my area generally are not taking subsidies. I just put that out for whatever it's worth. I'm not saying we are ahead of anybody, but we do have about 65% adoption rate of cover crops in this area here in the Mid-Atlantic. Pretty impressive, I might add. The other thing that applies more to your situation is the availability to specialized and narrow equipment for establishment of cover crops. Small seeders that can fit between your rows and so forth. That's a big thing. And even though they're not hugely expensive, it's an expense. Do you want to invest in that? I don't know if the NRCS has one available to rent. I would encourage someone to do that. That's a good way to get started. The other challenges, and these may be some of the more impacting challenges, is just the lack of knowledge. Just a lack of knowledge. Just don't know what's going on. I just don't understand. Like I said, we've gone through decades and decades of experience in growing our crops, and there's certain things that we understand and we know very well. But just getting that knowledge, that's why you're watching this today. You're doing that. I would encourage you to soak up as much knowledge as you can. Go to field days. Do your own research. Work with local researchers in your area and doing some things in your own vineyard. Sometimes you can get free seed that way. Try some things. And then your own experience. It's like riding a bike. You could watch videos all day about how to use cover crops in vineyards. You can, read books and all that. But you have to start on your situation to really learn how to make this work. So I will go into some details here, so I don't want to leave you too disappointed in that regard. So what are some of the considerations you need to think about in using a cover crop? Maybe your depth of soil. I'm sure you have variability within the state. I know you do. By the way, I've been to Oregon several times. I've been up and down the Willamette Valley, more to do with cover crop seed production. So I've been to your beautiful state a half a dozen times probably. I really wish I could be there with you today and drink wine with you guys. But so I can appreciate some of the geography and so forth, and the climate, rainfall and lack of rainfall cycles and so forth. But then you're going to be thinking about the soil types on your farms, which cover crops grow best in your type of soil, and then access to water is a big thing. And you guys all know that. I'm not going to go into that much. I just want to mention it here. What are some of the other cover crop influences? Well, one thing we know is legume cover crops, like the clovers, the peas, the vetches, they supply nitrogen. Here's where you're going to have to be careful. You're going to have to figure it out. You might want to take it easy in some of these because you could supply too much nitrogen. You don't want excessive vine growth. So that's, again, your seeding rate or maybe the mix you use. You need to consider that. The other thing is the water influence. Sometimes you're coming out of a wet spring, and I know a lot of you do, especially in the western part of the state, and that cover crop growing there can help dry out the soil a little quicker. That can be a disadvantage, maybe, if you're drier than normal and you have a water shortage. So what about terminating your cover crop? We're going to talk about that in a second. How does that work in the management? And I'm sure you're working with that. The other thing, and this is a little different dynamic, is how do cover crops influence the population of nematodes? One of the things that I grew up with was, when you said nematode, it was like, oh, that's a pest. You know that most nematodes are actually probably good. Very few of them are pests. And actually, one of the researches we did with the tillage radish that I helped develop, we found out that the tillage radish actually encouraged the beneficial nematodes that ate the parasitic nematodes. That's the way it worked. It didn't necessarily kill or terminate the pest nematodes. It increased the beneficial ones that ate the bad guys. I like to call that biological warfare. And once you understand how that works, it helps you manage it. So I'm just putting this out there. Some of you may not have any nematode issues. Fine. Some of you might. So this is something you might want to research. Another thing that has been a negative, and again, I'm just being upfront here, not all things about cover crops are positive. Now, there's no perfect system, right? So we got to acknowledge some things. Can impede downward air movement in slopes, and I won't go into all the reasons for that. Sometimes it may tend to attract frost, and that can be subtle, and sometimes that can be very important, for better or for worse, usually for worse in this case. So I just want to put that out there. Again, something you're going to have to consider when you're doing this. So now I wanted to show you just a few examples. This is some collections of pictures that I got from either people I've worked with or sites I've seen. This is in France. And if I was in person today, I said, so what cover crop is that? And someone would raise his hand and say, that looks like crimson clover. And I would say, you're right. So there's crimson clover, very popular legume, definitely one to try out if you're thinking about trying some. And then you always have that smart, I was going to say smart aleck, but I don't want to offend anybody who raised your hand. Are weeds considered a cover crop? Well, no, not really. But it might be better than nothing. I'll give you that. But you wouldn't use wild grapes for your variety to make wine, would you? There's a reason your varieties are selected. There's a reason we select certain plants for cover crops. That's what it's all about. So I say no. Weeds are not a cover crop. You want to use something that's going to try to do what you want to accomplish. You want to try to use a strategy to achieve the benefits, the full benefits that cover crops have to offer. So, what about specific cover crop species? I've mentioned a few. I'm going to put it back to you guys. Again, if I'd be there today, I'd say, so what's working in your area? What do you know? Start from there. I would also say, don't be afraid to try something new, at least something that would seem reasonable. Here's where you have your little, your groups, your mentors, or people you talk to. What do you think about trying, I'll just say an example, like hairy vetch. I'm not a vine grower myself. I'd be a little concerned of hairy vetch that it would get out and start growing up into your vines. That may not be good because it does that. So that's a question I would have, and I'm a cover crop specialist. But I would ask that question about hairy vetch. Not sure if that's a good one or not. And the other thing with hairy vetch, and I love hairy vetch, but the seeds can grow later on. That may be a good thing. It's because of the hard seed component. They may come up the next year. That may not be good. So a little caution out there about that. How are you going to manage this in your rotation? All these questions need to be asked when you start to talk about species. So I did list a few here. These are some that I know about. I'm not saying that these are the best because I don't know, but these are some to try. Some that I've known that all of these have been used in vineyards. So that's all I'll say right now about that. You're going to have to figure out which cover crop species and or mixes of them work for your area. Another nice picture from France. I wanted to show you this. This is in some cover crop research in vineyards. As you can see, this is a grass type. I'm not sure if it's triticale or cereal rye, but just thought I'd throw it to you there. Here's a mix. Look closer, you can see the purple flowers. That is hairy vetch. There's radishes, there's crimson clover in there. Looks like cereal rye. That now we're getting to the kind of thing that I'm talking about. A nice mix. I would caution you that hairy vetch though here. I want to show you a little example. A friend of mine that I got to know, I used to do a weekly webinar about cover crops. And this guy from New York, Western New York, he grows like 200 acres of Concord grapes for Welch's. And he was really interested because he was all into this. And he just peppered me with questions. And he sent me pictures. You can see there on the right, this is his tractor. I'm going to show you his roller that he's rolling it down. But he works with the unit with the NRCS. He works with Cornell. That's his university. Again, I want to encourage you to try to do that. This is how it looks now after that tractor passes, and his cover crop is rolled down with a roller. In this case, no herbicides. And this is his roller that you have. It's a narrow roller, specially built to go between the vines. And then on the picture on the right, this is later on in the year, we actually rolled it down and came in with a second planting of a cover crop that's designed to last through the winter. So this is like a multiple approach, 2 cover crop plantings in 1 year. And again, that may be a stretch for some of you, but this is what he's finding to be helpful. He sent me these pictures here. He sent me the picture on both these pictures from his farm. What was interesting, you see there's arrows are pointing to the earthworm holes, but the earthworms actually gathered, some of these are the leaf stems. They gathered them around their holes. We call that middens. I was surprised that the earthworms were that aggressive that they pulled that in there. On the right, you'll see where he dug out with a shovel. You can see the earthworm channels. So this is some of the benefits that we get with growing cover crops in our vineyards. We help the earthworms. We give them a happy home. And in this case here, they're opening up the soil, allowing water to infiltrate when you get rain, and so forth. So just some of the results of what we can do. Now I want to shift to a new topic that's about attracting beneficial insects, because some of you say, oh, I don't want anything there to attract, we usually say insects, meaning they're bad. I'd like to change our mindset. There's a lot of beneficial insects. If we manage this right, we can attract insects that eat our predatory ones. So this is just a picture here of an in-row option here where they're trying to attract beneficial insects. Does it attract pests? It can. And again, I'm just, being forthright. Until you get this figured out, there could be some, detriment effects here. But again, this is a system. Remember that? This is a system. And I'll guarantee you're going to have some small setbacks, even with the best education and the best advice. But you want to move forward with doing that in a way that when you're doing your research, make your plots small. I always like to tell people something that you can afford to lose if that's what happens, if things go awry. So I know there's a fine line here, but this is why you need each other to help understand how this works. And again, I don't have a lot of in-row options because I don't know many. I just know I've seen it. I had a picture of a local vineyard that was actually putting radishes in the row. They really liked it. I couldn't find a picture, so sorry about that. Couldn't find it. Some of the other issues to consider is, can cover crops affect the quality of the grapes? Can they affect the taste of the wine? The short answer is I've been told yes. So it's something you want to consider, something you want to talk about yourselves. Here south of you in California, here's a pretty much straight radishes grown between the grapes. I like to have mixes. So I'm a big radish fan, but I like to grow mixes. Well, here's one that's going to stretch you. If you're into regenerative agriculture movement, one of the pillars is putting animals into the system. This was when I was in Australia a couple years ago. And I took this picture as we were driving. They didn't want to stop because that's what happens sometimes when you're in another country. And at that area, you can kind of see there's sheep in there. Trust me on this. So they had sheep grazing in their vineyard. And again, I'm not going into the details of this. Some of you're really cutting edge in this. You might want to try something like that. So I'm just saying there's some people doing it. As I alluded to before, who are your mentors? I think this is really critical, and that's why I keep saying it. Again, someone who's doing what you want to accomplish. That's the key. If you choose a mentor that is maybe not supportive of the cover crops or soil health, and you want to go there, you're wasting your time. I would say too, if your crop consultant, if you have one, if they don't share your goals, maybe you should fire them. Or else, put it more kindly, get another one that shares your goal. Crop consultants can be a dramatic help, or they can be a hindrance, depending if they're serving your goals or not. So as I wind down here, as I wrap up my talk, I'm going to ask you again. I started out with this. Is soil health in your future? In your future? I would recommend you at least start looking into it and learn all you can. Some of the marketing things that I've been alluding to, and I know some of you have heard about this. I don't know to what extent it is going on currently in wine growing, but this is just a graphic I saw that actually literally is companies who have conservation plans, sustainability plans, regenerative agriculture plans that include soil health. So it's already happening. General Mills, makers of Cheerios, they're up to $6 million now that they have dedicated to research on soil health. It should tell you something. Why? Because they want to tell the story that the Cheerios that they're selling was grown in some sort of environmentally friendly way. That story is marketing, and it's really compelling. Just a quick one for me. You all heard of Wrangler Jeans. I've been a consultant to Wrangler, been down to their headquarters there on the left is in Greenville, North Carolina. This is what they call the Rooted collection. here, they actually, those jeans were made on, there's, I think, 5 or 6 farms in the US using cover crops and no-till and crop rotation. Go on their website, look up Rooted Collection if you want to see it. And so that's a marketing thing. Those jeans, $99. That's how much they cost. I've never bought jeans for $99. I have a pair now, kind of a little bit of a perk for working with Wrangler. But people would buy it because they're buying the story. And I just use this as an example. Wrangler took me to Thessaloniki, Greece, almost 1 year ago from now, because they're trying to launch this program throughout Europe. I'm just mentioning this just so you know what's going on around the world. That it's not just trying to get you to plant cover crops. It might be bigger than that, and you better pay attention. Another thing, too, I want to kind of wrap up with here is public perception. Now, this was the prettiest picture I had, so I saved it to the last. Who doesn't like that picture? Now, I can't tell you exactly what those flowering plants are doing, but can you imagine if you would put that picture on your website and you would say, this is how we grow your wine. We are trying to work with nature. That has value. And I can't say that will pay for your cover crops and pay for all the mistakes that you make in getting to here. But I'm telling you, there's something here. And again, you want to pay attention to it. Is this a valid opportunity, this marketing aspect? I think it is. Up until right about now, we have been pushed to do cover crop sake of the environment. Now I'm saying that's cool, but it may be a marketing opportunity. And that's actually maybe a stronger pull for some of you to have your story. What is your story? I'm asking you today, what is your story? What can you say that you're doing? What are you doing in your vineyard that counts as a soil health practice? I just picked out some names here. Forgive me if I'm naive, but what might E&J Gallo or the Willamette Valley Vineyards be requiring in a year ahead? I honestly don't know what they're requiring now, if anything. I just put it out there as a challenge for where the future may be going in this. So you kind of heard my talk, my passion about this. And if you want to learn a bit more, I have a book I just wrote called The Future Proof Farm. And it's the subtitle, Changing Mindsets in a Changing World. So if you want to hear my stories and just some of my worldview, my visits around the world, I've been to 13 countries, kind of summarizes a lot of what I'm really trying to say here. I see the soil health movement, the use of cover crops to be a part of the story so that you can better market your products in the future. And then the environment will take care of itself. At least that's how I look at it. See, I think that soil health is our future. I'm totally, totally convinced of that. This is me showing my first granddaughter her first earthworm. And that was almost an emotional moment for me. And because she was so curious. My daughter doesn't live on a farm. They live 2.5 hours away. So, when she was about 2 years old, I was able to show her her first earthworm. That was meaningful to me because I think it's in our future and so forth. So thank you so much for joining me today. I really appreciate it and look forward to meeting you guys sometime. Thanks.